Okay, this video is our first video in dealing with systems of equations. So let's first talk about what is a system of equations. So what we have is a system is when you have several equations. Okay, so the key is we're having two or more equations. And a lot of times we see them like written as in a bracket, saying, okay, all these equations are working together. Now the key is a solution to a system is a single point, okay, or a single set of answers that satisfies every single equation in the system. Okay, so let's look at this example here. We're saying this point right here is a point on both this line and this line at the same time. Okay, so how can we verify this? Well, let's take this point and plug it in. So let's plug it in that equation. So that's 4 times input plus y, which is another input variable. Okay, and we're going to plug in 3 and negative 6. So we're going to plug in 3 for x and negative 6 for y. So here we have 12 plus negative 6. Does that equal 6? And yes, it does. Okay, 6 does equal 6. So 3 comma negative 6 is a solution for the first equation. Okay, but it has to also be a solution for the second equation. You have to satisfy both. Okay, so let's go ahead and do it again over here. I'll do it in a different color. So we're going to have, I'm doing this equation right here now. So we have x plus 3y equals 15. And again, I'm going to plug in the same point, 3 comma negative 6. Okay, so we're taking this point and plugging them in right there. So we have 3 minus 18. Does that equal 15? Well, what we have here is negative 15. Does that equal 15? And we're going to say no. Okay, so here's the example. Is 3 comma negative 6 a solution? No, it's not, because it only satisfies one of the equations, not both. So that's a great example of saying, okay, we have a solution, but it has to satisfy everything. So we're going to spend this whole unit talking about system equations and different ways to solve them. So this is just a little intro to what systems are. Now let's look at the first method. The first method is graphing. Okay, so here we have two equations and they're in a system. We want to graph both of them and find the one point, the intersection that satisfies both of them. So let's start by graphing. Do this one in blue. Y equals 2x minus 1. So I'm going to start with a b of negative 1 and a slope of 2, 1. So up 2 over 1, and I have that pattern. I want to fill up the whole graph here best I can so I can see it good. And we want to be as accurate as we can in drawing this because we're going to use the graph to find our answer. Okay. All right, now I'm going to do the other equation in green. So we have positive 1 and a slope of 1 as well. So we get 1 here, 1 there, 1 there, slope of 1. Okay. And go back this way. So we can see that they have different slopes, different starting points. But at some point in time, they do intersect each other. Right there. Okay. So I kind of highlight that in red. And we can see that that's the point. Right there is the point where they're both crossing at the same point in time. So what is the order pair of that point? Where we go over 2 and up 3. So 2 comma 3 is the solution for both of these equations, okay? For instance, if I do the blue equation, y is equal to 2x minus 1, and I'm going to plug in the point 2 for x and 3 for y. Does 3 equal 4 minus 1? Yes, it does, okay? Let's go ahead and trust it for the green. The always thing about systems is you could always test your answer. So the green equation is y is equal to x plus 1. I'm going to plug in 2 comma 3. So does 3 equal 3? Yes, it does. So since it checks out with both equations, and we can see on the graph, what's the one point that is on both lines at the same time? 2 comma 3. So it's not two answers, it's one answer, one solution. Okay. All right, let's take a look here at another example. I'm going to do these three here. So I'm just going to graph them out. So the first one I'll do in red. So we're going to start at negative 4 and go up 5 over 1, up 5 over 1, and same down here. So draw this line through. Okay. Let's do the second line here in green. Now again, I'm going to solve for y first so I can get into some sort of graphing form. So y is equal to negative 2x plus 3. So I'm going to start at positive 3. Negative 2x will go down 2 over 1. Okay. You notice I'm being relatively accurate here as best I can. And we can see right here, here's the solution. This is the one point that intersects, and that is 1 comma 1. Okay. And again, we could plug it in and check our answers and so forth. So we're seeing this is the single point that satisfies both equations at the same time. Let's go ahead and show one more example here. Okay. Now notice for this first one, I see standard form, x and y are the same size. So I'm going to do intercept graphing here. Okay, so I'm going to solve for x and y. So let's solve for x here. Okay, so again, I'm going to cover up the y's, put 0 in. X is equal to 6. Good. All right, let's go ahead and plug 0 in for x, cover up the x's, and y is equal to 2. Okay, and we can see that right here. 3y is equal to 6. Okay, so now I got that done, I can take that off. So let's go ahead and graph that one. I'll graph it in red. So you have 6 comma 0 and 0 comma 2. And if we draw a line here, we can see our slope goes right about there. Let's get a couple more guide points here so I can see my slope and my pattern. Okay. Now the second line, I'm going to graph in green. And it's simply, some of us might want to rewrite it and put the slope first. So we can see a slope of 1 starting at 2. And there's this line. And here we could see that they intersect right at the y-axis, right here. It's doing a different color. And we see the point 0 comma 2. Okay. So here's 3 great examples of graphing lines and finding where they intersect. Now notice they all have different slopes and different starting points. So let's kind of talk about the 3 different scenarios that could happen. Here are the 3 different cases. So we have, you can basically get one solution, and that's the last 3 examples we haul. So this happens where we have 2 lines that intersect different slopes and they intersect at one point. So x comma y. So this is one solution. Now the thing is too, sometimes there's no solutions. What if the lines are parallel? So if I draw a line here and I draw a line parallel going in the same direction, notice they never intersect. So there's no solutions. There's none. So the key is they have to have the same slope. Okay. And on top of that, they have to have different starting points. So I'm going to make that note here as well. Okay. Now, infinite answers is, let's say we have a line, okay? And let's say we graph a second line, and it happens to lie right on top. So I'm going to do a different color. This a different line, which ends up being the same starting point and the same direction, okay? So in this case, they have to have the same slope, and they have to have the same and then the same starting point, okay? So that is the key here. Okay, so here are the 3 different scenarios of what could happen. And we're going to show algebraically how we test it, but on a graph, you're either going to intersect at one point, they're never going to intersect, or they're going to intersect all the time, an infinite number of answers, meaning I can plug in any x, and I'm going to get the same y for both answers. So there's a million trillion different solutions. Okay. All right, what I want you to do is these practice problems here. Let's kind of look at the whole page. So you have 3 problems in your notes. I want you to go through these 3 here. And that's a good way to start reviewing for this lesson.